Hey there, this is Peter. Welcome to another Take a Break with Valley CAD. If you saw one of our previous videos, we were talking about simulation and the introduction to it and how to apply forces to a part. We had some great responses on that video, and one of them was actually coming in and how to update your properties. Like, hey, I don't want to look in Newton meter squared, I'd rather look in PSI, or hey, I'd rather do pounds force. And so in this video, we're going to show you how you could come in and update the properties and also your plot for parts that you're doing simulations on. So get your favorite cup of coffee or tea. Let's hop on over to SOLIDWORKS to learn a little bit more about simulation. I'll see you over there. Hey there, welcome to SOLIDWORKS. So this is the same part file that I used when I did our intro to simulation video. And just to recap, this file is utilizing 1060 alloy, that's what's being applied to it. And also we are fixing it about these two holes here. And also we are applying 500 newtons across this counterbore. So as I was mentioning in the beginning of this video, we had some great feedback regarding our intro to simulation video, but we had some questions on it like, hey, Peter, is it possible to update your properties so that we're reading this in different units? Or what the heck is that rainbow thing on the right side of your screen? And last I checked, the letter E is not part of numbers. Okay, so I also want to point out that those of you that do FEA work every day, you're probably gonna laugh a lot and throw popcorn at the screen while I'm doing this. This is still an entry level of working with simulation. This is more of coming into the properties and also working with the user environment of SOLIDWORKS simulation. Okay, so starting off here, you'll see that we have a plot to the left side that's called a von Mises, and that's under stress 1, okay? So as I look at this rainbow thing is actually called your chart. And right now this is in a units of Newton meter squared. And you'll see here that we have this red arrow that's pointing out there. That red arrow actually correlates with your yield strength. So 1060 alloy has a yield strength of 2.757 E plus 0.7. Wait a minute, E. That's not a number, is it? No, it's not. Actually, it's part of a mathematical equation. Those of you that don't know that, exponential form. But sometimes that can hang people up. So that's why we're going to be showing this video, showing how to update the properties so you could look at different units on this guy. So von Mises is actually a really, that's the plot you want to see all the time. And this is looking at where you are yielding and where the part's going to fracture, also known as where it's going to break. And so this chart that you see here, this rainbow, the coloring that you see here gets applied onto your part file. So it's helping you out saying, oh, all right, so yeah, we don't have a lot of Newton meter squared here. Okay, cool. But oh, wherever it's red, not good. And also, by the way, as you look at your chart here, everything that's above that is technically gonna break. Just keep that in mind. We'll learn more about that here in a little bit when we look at factor of safety. So I wanna update this. How do you do that? Well, there's two ways that you can come in to look at the properties of your plot. If you have a plot that's selected, if you simply double click on it, that'll bring up your properties of your stress plot currently. And you'll see you have a definition, chart options, and settings. Under definition, what I want to do is come in and update my units. So instead of being in Newton meter squared, I want to make it so it's in PSI. And then also you'll see we have a deformed shape here. We'll come back and talk about that when we look at our deformation plot. Now what we're going to look at is our chart options. When we look at chart options, this all correlates with what we see as our chart, or the rainbow that you see on the right. So you can also come in here and say, hey, where do you want this chart to be located? Obviously that's too low because this head is covering up the yield strength. So I'm going to shift that back up. If I want it on the left side of the screen, I can do that as well. But I'm just gonna put it back. And this is also where you can come in and can fine tune where do you want this thing to be based off of the center or from the left side of your screen currently. And also where do you want it in relation to the top part of your screen. And also you can come in and change the type of thickness that you want on here. So if you want your rainbow to be thick, there you go. Or if you want it to be thin, there you go there. I'm gonna switch it back to normal though. All right, now what we need to talk about is what the heck is scientific? That's what's making all these E's show up. Come on, right? So how do we update this? And by the way, what is that E to begin with? Well, that's actually exponential form. And what this correlates out to, let's look at yield strength. It's 2.757 times 10 to the 7th power. And what that actually calculates out to is roughly 27,570,000 Newton meter squared. But I'd rather see that in that true entity number form instead of in exponential or scientific form. So if we want to see that in what's called a floating form, we simply click where it says scientific and click on floating. Bam, there it is for you. So as we look at this here, there's also one other one, and it's called general. General is kind of your hybrid between floating and scientific. Notice how it has a 3 there. This is not looking at precision of your beyond your decimal points. It's actually looking at, hey, when do you want to show this in floating or scientific? So as I start increasing this, like if I increase it up to 5, you'll see that my bottom cell there now shows us in a floating state. As I increase it up to 6, you'll see nothing change. As I increase it to 7, everything that had the power 6 on it now shows it in floating state. Okay, so that's how you can come in and change that. I'm going to switch this back down to 2 and go to floating. All right, so that's how you can come in and update these parameters. Now you'll notice that even though I set my definition as PSI, nothing here has changed yet. That's because I need to click the green check mark now. Bam. We now see that this part is now in PSI form for our stress, and our number notation has changed as well. Cool, right? So the other thing to look at here is I applied 500 Newtons force on this guy. Maybe I'd rather see this in pounds force. How do we go in and update that? You simply come over here to external loads and you'll see force. Simply right click on that and say edit definition. So instead of it saying SI for Newtons, scientific notation, I'm going to switch to English. You'll notice that here it says 112 now pounds force. That is the conversion from Newtons to pounds force for you. So I'm going to switch this down to 100 and click on the green check mark. All right. Now, after I did this, you'll notice that we have some triangles that are showing up under my properties, right next to static there and under my results. What's happening is SOLIDWORKS is saying, hey, you've updated some parameters here. You need to rerun your results here or your study to see the updated results. Okay, so I'm going to come up here where it says run this study. Simply click on that. SOLIDWORKS is going to crunch some numbers for me, and bam, there we go. Things are updated. You will notice that with my von Mises chart here that the red section has lowered itself a little bit more, mainly because I'm not applying as much force to it, right? Now, what we want to look at is displacement. So if I double click on displacement, I could double click on it again to bring up my properties, or I could also right click on it and come up here to settings. Okay, either way works. Now, what I want to look at is my chart options. And instead of being scientific, let's make it so it's floating. Hey, look, it looks a little more easier to read, right? And we'll make it so that we're in a precision of 3 decimal places over. And we'll say our definition. So right now it's in millimeter form. I'd rather make it so that it's in inches. Notice it still says in millimeters because I have not completed this, update of our properties. Now what we're going to do is look at our deformed shape. So right now it's set up as automatic. So it's at a scale factor of 260. So it's taking that 0.06 inches and multiplying that by 260. Woo, that's a lot. Let's see this in a true scale factor and click the green check mark. You'll now see here that it updated my chart to saying 0.002 inches on it. And also it doesn't look like the Leaning Tower of Pisa anymore. It is standing straight up, or so we think. To let you know in SOLIDWORKS, if you come in and you start zooming in on an edge and you see these little blips that show up on the side, that is a dead giveaway to tell you if something's vertical or horizontal, or if it's not. And in this case, it's not. Okay. And also with this chart, as you look at it, you'll see that it shows a different coloring plot on it, right? Wherever it's blue means it's barely moving, if any, and wherever it's red, that's the max amount of displacement. All right, so that is coming in and updating your properties as you work with SOLIDWORKS Simulation. Now, there's one other plot that's not visible that I would like to show you guys, and it's called a factor of safety. And with factor of safety, it actually goes hand in hand with your von Mises plot or your stress plot. Now, how do we turn on a factor of safety? You simply right click on the results folder, and towards the top, you'll see define factor of safety. From here, you have 3 steps to work through. The first one is selecting the bodies you want to calculate your factor of safety. In this scenario, we're just going to say all because I only have one body. Then you have a multiplication factor. We'll keep that at 1 as well. Now, step 3, it's going to ask us for areas below factor of safety or factor of safety distribution. In this scenario, I want to see areas that has a factor of safety of below 1. So you'll see here in this text that it says that my minimum factor of safety is 0.97. Okay, so where's it coming up with that calculation? Well, after I click the green check mark here, we're going to talk about factor of safety a little bit more. As I mentioned, factor of safety works with your stress factor there. What this actually means is SOLIDWORKS is going to come in, and actually this is across every FEA works, not just SOLIDWORKS. But factor of safety, the easiest way that I like to explain it is you think of capacity over your demand. Easy as that. So our capacity, well, capacity is looking at your yield strength. So the capacity of this file is actually at 3,999 PSI. Our demand that's being applied to this part right now is 4,116. So because our demand is greater than our capacity, we have a factor of safety that's less than 1, meaning something's going to fracture or something's going to break. Now let's look at this on our calculator here. So let's go ahead and bring up that guy right now. And so as I was saying, we want to look at capacity over demand. So if our capacity is 3,999.3, and I'm going to put that over 4,116.64 and push enter on that, you'll see that I have a calculation of 0.9714 there, okay, which is less than 1. If I come back to my factor safety plot, simply right click on it and we'll come into settings there, or sorry, not settings. I want to come up here and I want to go to edit definition. I'm so used to talking about settings with you guys in this video. I'm going to come back over here and I'm going to set it up, and look, see my factor safety says below 0.97 there. Hey, guess what? Calculates the same. Okay, so easily, like the most easy way to explain it is factor safety is looking at your capacity over your demand. If your demand's greater than your capacity, something's gonna break. All right, so as we look at our plot here, everything is blue except for that hole, right? And you can see here in our plot, it says, hey, everything that's below factor safety 1, make it so it's red, or everything that's above a factor safety 1, make it blue. All right, so hopefully this video helps out for you to kind of get familiar with your user interface of SOLIDWORKS Simulation. I hope you have a great rest of the day, and make sure you learn something new.